This is my Lab 3 circuits. So for an introduction, the purpose of this lab was to just understand the behavior of circuits. This lab gave me a better understanding about how circuits work and how manipulating certain aspects of the circuits affect things such as voltage, current, or flow. Some of the fundamental principles involved in this lab were the conservation of energy and change, Ohm's law, Kirchhoff's circuit laws such as the loops rule, and resistors for circuits in series and parallel. So for an overview, the lab was conducted in an online circuit construction kit since I'm studying abroad and did not have access to a physical circuit. To carry out this lab, I used batteries, resistors, ammeters, and a voltmeter to track the voltage across the circuit. For the RC circuit, I used a capacitor, light bulb, and a battery. I found that in the RC circuit, the current was based on the time with an exponential relationship. So here's the model that I used for the first part of the lab. I started with a circuit that contained two 1.5 volt batteries, two ammeters, and two circuits with 47 ohms and 100 ohms. At this point, I recorded the potential difference at different points in the circuit. So for the experimental data for part 1 of the lab, the voltage between A and B was 3 volts, then B and C went to 0. Between C and D over the resistor, it was negative 0.96. D and E 0 again, and then negative 2.04 over the other resistor, and then for the rest of it, it was 0 volts. There's the chart labeling A, B, C, D, E, and F, H and G, and then the graph that I had for the data. So for analysis of part 1, when I removed the top ammeter and took a voltage reading, it still gave a number even if the circuit was still open because it just reads the voltage at 2 points without considering the current. When you reverse the input of the ammeter, it still reads the same 0.02A, and when I added a parallel circuit in the system, the ammeter then read 0.06 since there's less resistance in the circuit. For the second part of the lab, we built an RC circuit when kind of measuring what happens when you connect a light, battery, and a capacitor. What happened to the light when it was first connected to the battery and the capacitor, the light starts to dim slowly, and then after the connection, the current just starts to slow down until 0. When you remove the battery, the light is illuminated and gradually dims as the capacitor is getting kind of discharged. And the time that I recorded to charge the 10 ohm bulb was 2.68 and 3.2 to discharge. And then with the 20 ohm bulb, it took 4.83 to charge and 5.93 to discharge the capacitor. So here's the results and the time versus voltage in my RC circuit that I recorded across 0 to 20 seconds. And then when you take the natural log, you can see that it creates a linear relationship because it was exponential. So discussion. What if I was using a real ammeter instead of a simulated one? It is likely that unlike in the simulation, the ammeter would have some resistance, so it most likely would not have had truly 0, which could have led to a lower current with the added resistance, unlike obviously in a perfect situation when I'm simulating it. And what would happen if I was using a real battery instead of a simulated one and had no resistor in the circuit? If there's no resistor, then this would mean the capacitor would charge instantly, because with no resistance, the potential difference would go down to 0, and there would be no resistance, so it would charge immediately. In real life, the capacitor would not actually charge instantly because the wires would contain some resistance, again, unlike in the simulation that I did where it didn't have any resistance.